While being stuck indoors for weeks and trying to escape the cold mountain weather as well, I have been thinking about how excited I am for summer. One of my favorite things to do in the summer is spending time with my family and snacking on some juicy watermelon. There is only one problem. There never seems to be quite enough watermelon for everyone. So I was thinking, how could I increase the size of the watermelon, allowing for everyone to get one or more slices? This is when the idea hit me. I should create a mass selection experiment using the top 10% of my watermelon population to increase the diameter of a watermelon. My watermelon population had a broad sense and realized heritability of 0.85 and 0.67. This is where my experiment began. I started out by finding the average diameter of watermelons in my population. My population of watermelon had a mean diameter of 10 inches and a standard deviation of 2.5 inches. My next step was to find the top 10% of watermelon diameters in my population. I discovered that the top 10% of my population had an average diameter of 14 inches. I decided I needed a cutoff point of my parent population. This point would be known as my truncation point. A truncation point is where the phenotype is above or below a certain value and is selected as parents for the next generation. The value that I calculated to be my truncation point was 13.205. I then extracted the seeds from my parent population, planted them, and waited on the next generation of watermelon to grow. As I was waiting on my new population of watermelon to grow, I had some time on my hands to calculate the selectional difference. My selectional difference was 4 inches. Months later, my new generation of watermelon had grown, matured, and were ready to be measured. As I was measuring my new generation of watermelon, I was pleasantly surprised. My mean of the offspring population was 12.68 inches in diameter. Now that I wanted to compare my original starting mean with my new offspring's mean, to calculate my response from selection, I discovered this value to be 2.68 inches. With this information, I was able to discover that I had successfully increased the average diameter of my watermelon population. I then got the idea to increase the diameter more through many rounds of the plantation process. As I thought about the constant increase of diameter, I realized a major problem I would end up facing. As the diameter of the watermelon increases, it not only increases the edible juicy fruit, it also increases the rind. By continuing to increase the diameter of the watermelon so heavily, the rind would end up increasing so drastically that there would be almost no edible fruit found inside, only rind.